Blockchain.
Blockchain.
Blockchain technology has changed the way digital security works, using decentralization and cryptographic hashing to make secure, transparent transactions without needing a central authority. It is widely used in industries like finance and supply chain management, where security and trust are essential. Each transaction is stored in a block, verified by network participants, and linked in order to previous blocks through unique hashes. This linking makes the blockchain secure because altering one block would mean changing all following blocks, which would require enormous computing power. Consensus methods like Bitcoin's proof of work, POW, prevent fake transactions, adding security by requiring complex mathematical proof before adding transactions. Decentralization further protects the blockchain, as records are spread across many nodes, removing single points of failure and lowering vulnerability to cyber attacks. However, some risks remain, such as software bugs and attacks on related components like cryptocurrency wallets. Blockchain's anonymous nature can also make it harder to trace illegal activities, leading to more regulatory focus. While blockchain offers strong security, challenges require ongoing efforts to keep it secure as the technology develops. Despite its security, blockchain is vulnerable to various types of attacks. One significant threat is the 51% attack, where a single entity gains control over half the network's mining power or stake, allowing it to reverse transactions and double spend. Larger networks are more resistant to this, but smaller networks remain at risk. Weaknesses in smart contract code are another risk, as poorly written or unchecked contracts can be exploited, like in the DAO attack on Ethereum, which led to major financial losses. Phishing attacks trick users into giving up sensitive information like wallet passwords, which attackers then use to steal funds. Routing attacks intercept data between blockchain nodes, potentially isolating parts of the network and creating conflicting records. Replay attacks exploit blockchain forks, letting attackers resubmit transactions on a forked chain, causing discrepancies. Side-channel attacks, which target the systems around the blockchain rather than the blockchain itself, are also increasing as blockchain connects to other technologies. Protecting blockchain systems requires thorough audits, user education, and network diversity to defend against these weaknesses. Improving blockchain security requires layered approaches that include technical, operational, and procedural improvements. Regular code audits and quality checks are essential because any vulnerability in blockchain code can be exploited. Independent audits can help identify weaknesses before a system is launched, preventing potential losses. Strong access controls, like multi-factor authentication and identity checks, are also critical for limiting access to sensitive areas within the blockchain. Secure communication between nodes through advanced encryption is essential to prevent data from being intercepted. To reduce the risk of 51% attacks, having a diverse mining pool promotes decentralization, making it harder for any single entity to control the network. For high-value transactions, especially in finance, continuous monitoring and behavior tracking can catch fraud early, allowing quick action. A well-planned incident response, combined with regular breach simulations, can reduce the damage from potential security issues. Education for both developers and users is just as important, creating a secure ecosystem where security is prioritized in all areas of blockchain applications. Together, these measures help strengthen blockchain, ensuring it continues to be a safe digital solution. Real-life cases of security breaches show the importance of strong defense and quick responses in protecting digital assets. The 2017 Equifax data breach exposed the personal data of 147 million people due to a weak point in its web application. Equifax responded by shutting down the compromised system, offering credit monitoring, and improving its cybersecurity setup. The 2016 Bangladesh Central Bank attack shows how weak internal security allowed hackers to steal credentials and attempt a $1 billion theft via the SWIFT network, with $81 million actually transferred. The bank, with international help, stopped further transfers, highlighting the need for strict security measures in international transactions. The 2014 Mt. Gox hack, where 850,000 bitcoins were stolen due to software flaws, showed the specific risks facing cryptocurrency. This incident led to legal actions and attempts to recover assets, emphasizing the need for secure storage solutions. These examples show that recovery from breaches can be long and complex, involving technical, legal, and regulatory actions. Learning from these breaches helps build stronger defenses and supports a secure digital space. As blockchain technology spreads into more areas, ongoing improvements in security measures are necessary. Decentralization, the main feature of blockchain security, spreads data across many nodes to lower the risk of tampering and system failures. But large, high-value networks attract more complex attacks, needing stronger protections. Innovations in cryptography, like quantum-resistant algorithms, aim to protect blockchain from future threats posed by quantum computing. New consensus methods, such as delegated proof of stake, DPoS, and proof of authority, POA, are being introduced to improve blockchain security and ability to scale. Smart contracts, which are key to many blockchain uses, require perfect code to avoid exploitation, which is driving the demand for code audits and tools that mathematically verify contract behavior. New monitoring algorithms and Byzantine fault tolerance (BFT) protocols are helping to detect and address centralization threats like 51% attacks. Cross-platform security solutions are also necessary as blockchain systems connect with the Internet of Things, IoT, and traditional finance, ensuring secure data transfer between different networks. Education and training are important as well, raising security awareness among developers and users. This evolution, with both tech advancements and greater user understanding, strengthens blockchain's defenses, supporting its increasing use in different applications. As blockchain becomes more widely used, future security trends show how the technology may adapt to meet new challenges. Quantum-resistant cryptography is a key area, with researchers developing algorithms to withstand potential quantum computer attacks. Improved privacy methods, like zero-knowledge proofs, offer ways for sectors handling sensitive data to verify transactions without exposing unnecessary information. More decentralized security models are expected to lessen reliance on centralized parts, like mining pools, reducing risks such as 51% attacks. Cross-chain security solutions are also likely, allowing secure interactions between different blockchain networks without needing intermediaries, which would improve efficiency and scalability. Artificial intelligence, AI, is expected to play a bigger role in blockchain security, with machine learning tools able to detect unusual behaviors in the network and simulate attack scenarios to help identify weak points. Standardized security protocols and regulatory guidelines will become more important as blockchain integrates into mainstream finance and governance, offering consistent security and building trust. Additionally, specialized education programs and certifications in blockchain security will create a skilled workforce to handle new security challenges. Together, these trends show blockchain's proactive steps to keep up with sophisticated threats, ensuring it remains a secure and reliable technology across industries.